Hey, welcome back to episode 2, video 3 of the state tree tutorial series. In the last episode, we finished up the patrol state. We also created the state tree and hooked it up to the AI controller. And in the episode before, in episode 0, we actually made a plan of what we're going to be doing throughout the series. So if you haven't watched those episodes, definitely give them a watch. There's a lot of good information in there that I'll be referencing in this episode as well. But for today, I think I really want to focus on getting the chase state and the attack state implemented. There's also going to be a little bit of a twist that happens later in the video, so hopefully you enjoy that as well. But yeah, without further ado, let's go ahead and hop right in. If you're planning on following along, I have the project file after episode 1. So this has the chase state, the patrol state, and the AI controller and the state tree all set up. So if you followed along with last episode and you basically want to download the version of the project that we ended off with and that we're going to start off with on this episode, go ahead and just go here and download it. But let's go ahead and take a look at the requirements that our designers gave us. So if the enemy sees the player, it needs to chase the player until it reaches a given attack radius. So one thing that I'm noticing off the bat is that we have a ifs statement here in the design request. This is asking for if the enemy sees the players. Already we know that we need to use the AI perception system, and it needs to chase the players. We're gonna have some kind of moving as one of the tasks until it reaches an attack radius. The biggest thing that I notice here is like the if statements. So something that I want to point out for if statements is there's a couple ways we can do this. We can either have something that checks whether the enemy sees the player every single frame, or we can use a event-based workflow. The state tree system supports both. Actually, in fact, Unreal's built state tree system that they use for their variant shooter pack, they actually use the tick version where they're checking every single frame to see if the enemy sees the player, whether they have line of sight or whatnot. We're not going to be doing that. We're going to be using the event-based system. There's not really a wrong way. It's whatever works best for your project. So what I'm going to do is I'm going to go ahead and I'm going to go to programming. I'm going to go into the state tree right here. So let's go ahead and let's add another child of the root, and we'll call this found player. And bear in mind, I'm referring back to this plan that we made here, where we have the no player and then the player found. Player found is going to have the chase and the attack, and the no player will have the patrol. So let's go ahead and get that set up. So we have found player and no player, and under here we're going to have a child state called chase. We're going to have a child state, or a sibling state actually for this one, and we're going to call this attack. So now what we're going to do is we're going to set up transitions between the no player and the found player. Like I said before, we can actually use the tick, and what the tick does is that it allows us to transition to a different state, and we can actually give a condition that needs to be met. We can make our own condition by making a condition from here. You can see they already have a has line of sight to target condition. You want to return some kind of boolean whenever you make a condition. You have bool compare, we have distance compare, enum, float, etc, etc. I'm not really going to be using on tick. Instead, I'll be using on event, which is a different kind of setup that we need to do. For this, we actually need to go to the AI controller. So the way we're going to set this up here is first, I'm going to go ahead and add a AI perception. What I'm going to do is I'm going to go to the census config. I'm going to go ahead and add the site config. Now we can add other ones, but our design docs only mention the site, so that's all I'm really going to add. And I'm going to open this up here, and I'm going to edit some values. So site radius, I'll keep it, we'll say 1,000. And loose site is 1,500. Now, unfortunately, we actually can't edit these values with blueprints. You'd have to use C++ for that. So I'm just going to set these up manually. If you're using C++, you can actually make variables in the data asset that I showed last episode and use that to control these. So I'm going to set peripheral vision to 45. Detection, I'm going to set it to all 3. But one thing we can do is we see a couple of events here. The main ones we're going to be using are on-target perception updated and on-target perception forgotten. Let's go ahead and add both of these. So the way I'm going to set it up is we're going to talk about state tree events. So one thing that I'm going to do here is I'm actually going to first check to see if this is equal to the player character. Now, if you have a different way of detecting whether this actor is a player character, maybe like an interface or some sort of function, you can go ahead and do that. For now, because our game is very simple and our planning is very simple, I'm going to go ahead and use get player character. I'm going to create a branch node. You can hold down B and click to create a branch node anywhere you want. And I'm going to connect this up. So if this is the player, one other thing I'm going to check is I'm going to go ahead and grab this. I'm going to type in break. So these are all the values we get from the AI stimulus. I'm going to go ahead and check to see if we successfully sensed the player. So whenever this returns true, it means we've sensed the player, we see him, we're good to go. If this returns false, that means we've lost the player. I can actually get rid of you because we actually don't need the on target forgotten. The fun thing we're gonna do here is whenever it's true, that means we've sensed the player. I'm gonna go ahead and grab the state tree AI component, and I'm gonna do send state tree event. So this is how you send an event to the state tree. You can basically pass an event from outside the state tree to a state tree, and this is how you would do it. Now, if I right click and split struct pin, you'll notice a couple things. One, it's asking for an event tag and an event payload. So the way this works is if I go in here and I go to no player and I add a on event transition, you'll see it has the exact same values. It has a tag and it has a payload struct. So what I can do is I can create a structure. So I go into data and I go to blueprint and I create a structure, and I can define whatever kind of data I want in that structure. And if I mention that structure here in the transition, right here, I can actually pass in whatever data I want through this event payload, which will be me passing in that struct into here. Right now, we don't really need to pass in any data, so I'm not really gonna worry about that right now. Now the gameplay tag, that's where things get a little bit funky. So this isn't like a normal event dispatcher where you just give it a name and you type in whatever variables you want to pass the event. This is a little bit different. The gameplay tag that we pass in is basically the label or the name of the event. So what I'm going to do is I'll show you how to set up your own custom gameplay tags. Let's go into the content drawer and let's go into programming data. We're already here. I'm going to right click. I'm going to go to miscellaneous, and I'm going to click here where it says data table. And I'm going to click this drop down and click gameplay tag table row. I'm gonna call this DT gameplay tags. In here, and again, this setup is kind of weird, but I just wouldn't worry about it. Gameplay tags are really interesting. There are so many videos that talk about how in-depth they are. For now, we're just gonna pretend that they're names. So I'm gonna add a new row to the data table, and I'm gonna change the name of this tag to state tree.foundPlayer. And I'm gonna add one called state tree.lostPlayer. Now technically these don't have to be state tree.lostPlayer or foundPlayer. They could just be lost player or found player. The reason why I like to add the state tree dot to them is it groups them up together so that it's easier for designers, or it's easier for even us to actually be able to edit it. So in order to add this data table to the project, we have to go to edit, project settings, and here we have to go to gameplay tags. Let me go ahead and get a reference to this. So here, we need to go to gameplay tag table list, click add element, and I can just bring this in here, the DT gameplay tags right here. And we should be good to go. If I just control S, it's gonna go ahead and save that. And now what's cool is whenever I go to the AIC state tree, I can give this event a name by saying, clicking on this, the dropdown, and you'll see here it has state tree, and it's grouped found player and lost player inside of state tree. So I can actually do found player like so, and it'll send an event named state tree.foundPlayer to our actual state tree. We'll do the exact same thing here. If it's false, which means, and bear in mind, a false means that we lost sight of the player, but I'll change this to lost player. Alrighty, so now we have our events set up, and we're actually passing these events to our state tree. And there's a really easy way to handle it. So on no player, we want the transition from no player to found player whenever we have the found player event. So let's do transition, let's do on event, and for the required event, let's change the tag name to state tree found player. So with this, let me actually, hold on. I forgot to set this to the actual state, so let's do found player. So what this means is whenever we get this event, whenever the state tree hears this event of state tree.foundPlayer, it'll immediately transition to the found player and run the attack, or run the chase and then the attack. And same thing here, we'll add a transition, do on event. We'll set this to state tree lost player, and we'll go ahead and we will transition to no player. So here's the thing that I was talking about earlier. Because this is a hierarchical state machine, this event is listening even while these child events are running. So no matter what event we're in, if this hears the statetree.foundPlayer event, it's gonna immediately go to foundPlayer. Same thing here. Even if we're in the middle of attacking, if this hears the statetree.noPlayer or lostPlayer event, it's gonna immediately go to noPlayer. So that's the really cool part about it. Let's go ahead and set up chase while we're here. How do we want to do this? So what we need to do in the AIC state tree, let's go ahead and let us, how do we want to do this? I'm going to do something a little bit interesting, actually. I'm going to go ahead and keep a reference to the target, and we're going to call this bad boy actor, and have it be an object reference. And from here, whenever it's true, I'm going to go ahead and get a reference to the actor. Let me set this target right here. By the way, you can always do a set really easily by holding down Alt, and that'll do a set. Holding down Control will do a get. That way, whenever you drag it out, you don't have to choose. You can hold down Control for a get and hold down Alt for a set. But I'm going to go ahead and set this to actor. And actually, what I'm going to do is I'm going to do the set first, and then I'll do the state tree event after, because that transition will happen almost instantaneously, and if it doesn't find a target, it might throw out an error, so we want to set this first. And for here, I'm going to go ahead and just set it to nothing. So this will set it to a non-valid value. Try saying that 5 times fast. And so we can even use that to compare and see if we need to do anything about the various transitions. So what I can do here is for chase, I can actually say, hey, we're going to do an AI move to, and instead of destination, we're going to do target actor. So I'm going to select here. I'm going to click on, or find the AI controller with the arrow next to it and click on target, because that's the variable we set up in the AI controller. And there we go. And for acceptable radius, I actually want to go ahead and create a variable in here. So I'm going to do attack radius, because that is the radius that was mentioned in the notes that we got. We need to, it'll chase the player until it reaches a given attack radius. So let's go ahead and make this a float, and I'll actually do is change this to attack, so that it's properly organized in the primary data asset. And we can even change this to centimeters. Cool. I'll go ahead and let me go to the design data asset. And here I'll go ahead and set a attack radius of, let's say 50 centimeters. That's good enough for me. I can even make it 100. Just so we can mess with it a little bit. And what I'll do is an acceptable radius. Excuse me. I'll go ahead and click here, go to parameters, go to enemy settings, and go to attack radius. Cool, so now it's all hooked up. What we'll do next is once we've reached it and the task has succeeded, on state succeeded here, we're gonna go ahead and transition to the next state, which is attack. What I'm gonna do is, we're just gonna do the attack right now in this episode. If the player is within the enemy's attack radius, the enemy will attack. So we need to create a random placeholder shoot function for now. What I'm going to do is I always like my attack functions or functions that involve events happening in the actual world itself to take place in blueprints that exist in the world. So in that case, I'm going to have my attack logic just be on my blueprint enemy. I'll add a custom function or custom event, and we'll call this attack. Actually, they said to call it shoot, so let's call it shoot. And just for now, I'm gonna go ahead and print out some text. I'm gonna say BP player or enemy, and I'll give, say, shoot. Okay. And now we can actually make a task that calls that function. So in here, I'll do new task. I'll inherit from STT base, go to tasks, and do STT attack. From here, I'll do a enter state because we want to run this whenever we enter that state. I'll grab reference to the pawn, and I'll call the shoot function or shoot events like so. Now, we also could have a possible delay between our attacks, and there's a really easy way to do that as well. One way we can do it is we can have a wait underneath our attack. So after attack, it'll go to a wait, and wait will go back to found player. There is a different way to do it though, and I'm actually gonna do it in the other way just because it's slightly easier. What I'll do is we need a reference in this one to the actual delay between attacks. So I'll do delay between attacks, and I'll make this a float, and we'll go ahead. I'll just make this visible. I'm not gonna make it an input, although I will be binding to it, so I'll make it an input. I've been convinced. Yeah, I'll go ahead and make this an input, and what I'll do is I'll add a delay node. And I'll go ahead and plug in the delay between attacks. And only after this is done, I'm gonna finish the task successfully. So what this does is that this adds an automatic delay in. So whenever I add the STT attack, it's gonna delay this. It's gonna delay the state being completed until that delay between attacks is done. So let me go ahead and add that as well. I'll go ahead and add a new variable and say delay between attacks. And in here, I'll go ahead and make it, let's do 3 seconds. I like 3, good number. And now I can bind to our data asset by going to parameters, enemy settings, delay between attacks. Alrighty. So after we're done with this state, we don't want to go back to the root. We actually want to go back to chase just to make sure to just see if we're still within range of attacking, because it'll automatically go to the root or the attack if we are. Let's go ahead and do on state completed. Let's go to chase so that these two keep looping essentially forever until we get that event saying, hey, we lost the player, and then it'll just go back to patrol. So now if we go ahead and run it, you'll see right now it's on patrol. You see in the top right corner. If it ever sees us, it's going to go ahead and it's in patrol again. If it sees us, hello, can you see me? Okay, you can't see me yet. Hello, please see me. It's right now. Okay, so it's in chase, and now it's back to patrol because it lost sight of us. So it's now chasing us. It's attacked us, and hello, chasing us. It's gonna keep chasing us. But once it loses sight of us, it's going back to patrol, which is exactly what the design team wanted. So yeah, that's basically it, I think. Oh, whoops. Turns out I got a message from our designers. Ignore the really bad paint job. Oh no, guys, these designers, turns out we need the enemy to search the last known location of the player when it loses sight of the player. By the way, sorry, please, and thank. So I guess we got more work to do. But this is a good lesson on how to refactor and rework some stuff. Essentially, we need a way to figure out how to store the last known location and how to get it whenever we lose sight of the player, how to make the enemy go to the last known location, possibly even wait there, and then move on to losing the player if they need to. Let's go ahead and head back to here. Let's go to our AI controller real fast. And whenever we lose sight of the player, instead of immediately canceling this out, what we're gonna do is I'm gonna go ahead and I am going to store the last known location that we have. So I'm gonna go ahead and get another reference to this payload here, where I open up the stimulus location, and I'm gonna go ahead and make this promote this to a variable, and I'm gonna call this variable last known location. Cool. So whenever we lose the player, we're keeping track of the last known location. What I'm going to do is I'm going to go to the state tree, and instead of going from found player to chase back to no player, I'm going to add another child state. We're going to call this search last known location. This what I'm gonna do here is whenever we lose the player, instead of going to no player, I'm gonna go ahead and go to search last known location. And in here, what we want to do is we want the enemy to move to the last known location, to wait there for a bit, and then after that to go to no player. So I'm gonna go ahead and add a, I'm gonna do all those tasks here in the actual, in this one state right here. The reason being is I don't have any reason to split it up or to have it wait. Actually, you know what I'll do? You know what? I completely lied. I'll add a child state and I'll say move to last location. And I'll add another child state and I'll say wait. So we do need to wait after it reaches the last location. So here, I'm gonna go ahead, first things first, at the last known location, I'm gonna add a transition here. So if we're in the searching last known location state and we receive an event saying, hey, guess what? We actually found the player again. I want to immediately transition to the found player. I don't want to worry about anything else. I want to immediately go to found player if we get an event that we've actually found the player. But here in the move to last location, I'm going to add a task that's AI move to. And because we're storing the last known location here, what I'm going to do is I'm going to go ahead and for destination, I'm going to bind it to the AI controller last known location. And it's going to go ahead and move to there. If that state has completed successfully, we're going to go ahead and we're going to transition to the wait. And in wait, it's just going to be a delay task, and for however long we want it to be. So I'm actually going to make another setting in here. I'll do search wait, and I'll actually put this in the search category. I'll make it wait for about 4 seconds actually, because I'm quirky like that. And then I'll change this to read from the parameters, enemy settings, search wait. Okay, so it'll wait for that long, and after it's done waiting, after we've completed the state, we're gonna go ahead and go back to patrol. Cool. So one thing you might notice here in the chase and in the move to last location, it's gonna go ahead and go to the route. So here's an interesting thing that I want to be able to do. So basically the interesting behind this is that, for example, in the chase, if this AI move to for any reason fails, or like we just can't get to, the enemy just can't get to the player, it's not gonna waste any time. It's gonna go ahead and go to the route. If we wanted to, we could actually have a on state failed transition and have it go to somewhere else. But for now, I'm just gonna leave it to go back to the route. Same thing here, if we're trying to move to the last known location and for some reason we just can't, we're just gonna exit out and just go to patrol instantly. I'm not gonna wait around to see if I can try to find a location there. So now that we have that, we actually have it searching the last known location. And once it's done searching, it's gonna go back to the route, and it's gonna go back to patrol, and it's gonna keep patrolling forever. So let's actually try this out and see how that looks. Okay, so right now it's patrolling. We're gonna wait for it to see us. There you go, it found us. It's running after us right now. We found the player. If I keep running, and if I go up here, it's gonna go ahead and keep running after us. Or it's try its best to, I believe. I don't know where it is. It's actually, what is it doing? Ooh, holy lag, Batman. But yeah, now you can see it's actually gone back into the, what is it called? It's gone back into the patrol mode. We've exited the, now it's found me again. It's gonna go ahead and try to chase me. But after a little bit, it's gonna go ahead and go back into patrol. See, you can see it went back immediately. So let's actually add a bit of a debug text so we can see that. So I'm gonna go add a debug here. I'll change this to all actually. Let me add a debug screen and we'll say searching for player. Cool. So now I can go back here. First things first, if he's able to find me, he'll chase me. So right now he's in patrol. He didn't look at me at all. I don't know why. But now he's chasing me. Oh, he's still chasing me. That's kind of scary. And he actually shot me. Jesus. But now he's searching for me. He doesn't know where I am. And now he's back on patrol. So there we go. We've added not only the a base player or a base enemy kind of logic, but we've also added searching last known location. We've added the attacking, basically. We've also added forgetting and then moving on, stuff like that. And what's fun about this is that whenever a designer wants to change that data, all they need to do is to go into their design folder, go into data, go into this data asset, and mess with these settings. And that's basically it. That's all designers need to do. They don't need to worry about any of the state trees. They don't need to worry about anything else. That's all they gotta worry about. So yeah, that's basically all we're gonna do for this episode. And in the next episode, I'll go over how Unreal has their own state tree set up, and we'll actually walk through it and see how the functionality works there. I actually want to take a second here and point out something that I forgot to do that I probably should have done. I'm going to quickly talk a little bit more about the state tree system and a little bit more about the individual components of it. So a different thing that we could have done is we could have messed with enter conditions, and these are essentially statements that evaluate the true or false. And if it's true, it'll go ahead and enter into that state and run what it needs to. If it's false, it'll just ignore that state and move on to the next one. The reason why it does that is because this root is constantly trying to select the children in order. So this root is constantly trying to run no player and then found player and then search last known location. But if no player has an enter condition that evaluates to false, it's gonna move to the next one. Now the interesting thing is the root doesn't control the transition between these. So when we're in a child state, this child state is solely responsible for its transition to whatever state it wants to. So if we're in the root and we're in the no player state, the root's not going to say, hey, no player, you're done, we got to move to the next one. The no player state is responsible for its own transition. But the root will always try to select the topmost state first, because that's what we're doing here. If no player the enter condition is evaluated to false, it'll move to found player. If that's evaluated to false, it's going to move to search last known location. You'll actually see this come up when we actually look at the or Unreal's version of their state tree. But for now, I didn't feel the need to do it just because our system works and it works with what we have. But you can go ahead and use it if you need to. We also have selection utility. So what's cool about state trees is that they actually work with utility AI, which is a system of selecting an action based on its score. And you can determine score by giving it its own weight. Actually, if we try to select children with the highest utility, we can actually add various utility stuff. So we can add constants, we can add floats, we can add whatever we want. If I do a enum input, I'm comparing enums here, it's this whole thing. Or I can do a float input and essentially give it a response curve that it checks along that curve to see how to evaluate something. For example, if I have a value that's called hunger, and if it goes from 0 to 1, and the more hungry you are, I can add a point, I believe. I add key to curve. I can even say, hey, the more hungry you are. Yeah, so if we're at 0.5 hunger, we're not in danger at all. But if we're at 1 hunger, this is gonna be at 1, which means we gotta do this. The higher the selection utility is, the more likely it'll be chosen. But that's only if you're trying to select children with the highest utility. Generally, I always just try to select children in order. Just because I always order my states with intention. But you can try the different selection utilities, see which one works best for you. And if you hover your mouse over this, it'll actually tell you exactly what they do. So yeah. Tasks, we've already kind of gone through this, and transitions, we've already explored this as well. What's fun is states can have their own parameters that apply to child states, I believe. So if I have a parameter here called, let's call this new property. Actually, I'll make this a vector. What's fun is in the pick a patrol point, if I try to move, I should be able to find. Yeah, so I can go to root and find the parameters in the root and click on the new property. So that's another way you can do it. I usually don't mess with parameters inside of states, but I know they have a good reason for existing. If you want to store some data, but you only want it to exist whenever we're in that state, this is a perfect way of doing it. Generally, I've always seen it recommended that whenever you have something in the global parameters, you don't really want that to change. And I think that also applies to the state parameters as well. Parameters are generally only really meant to be read-only data. You're not really meant to change that data or modify it. The difference is for global tasks, you are allowed to modify that data. For example, if I had a task that was modifying different data, I could actually bind it to anything in the global task and actually modify it there. Same thing with evaluators. If I wanted to have some data that can be changing, I can actually keep it in an evaluator or a global task and use the tasks on the states to actually modify that data and read it from elsewhere. Themes is super fun. I love having different themes, so I'll set this one to a patrol. I'll create a new one called found player, and I'll create a new one called search. For found player, I'll make the color into like a more reddish tone, make it a bit darker so that the white stands out. And for search, I'll make it more yellowish, although it's looking not looking the way I wanted it to. There you go. It's definitely more brown, but that's okay. And you can control click these states, change this to found player, control click these, change this to search. And yeah, so that's basically most of the info about the state tree. That's usually how you'll work with it. And we'll talk about how Unreal does it, and we'll show some cooler things in the next episode.